In this lecture, what we are going to discuss means, we are going to discuss about 4 different topics. So the first one is data encryption standard. Second one, triple data encryption standard, advanced encryption standard, block cipher modes of operation. So these are the 4 topics we are going to discuss in this lecture. All the 4 topics, okay, it is 4 short answers. Okay, 4 short answers. In sometimes they may ask this in the long answer also. Okay, because it is a very important concept. All the 4 are very important concepts. Okay, what is this? Means data encryption standard. Data encryption standard means this is an algorithm. TES is an algorithm. Okay, it is a symmetric key encryption algorithm. Okay, so this is, we already discussed in lecture number 2. What are the 2 types of encryption? Symmetric encryption and asymmetric encryption. In symmetric encryption, we are going to use only one key, okay, for encryption and also for decryption. Okay, so now for example, for symmetric key encryption, these are all the examples. Data encryption standard algorithm, triple data encryption standard algorithm, okay, TDES, triple data encryption standard algorithm, then advanced encryption standard algorithm, AES. So these are all the examples for symmetric key encryption. Then the next one is, we are going to discuss about the block cipher modes. In the previous lecture, that means in lecture number 2, we discussed about what is a block cipher. So block cipher means stream cipher, block cipher. There are 2 different types available. For stream cipher, it is going to take 1 byte at a time. Okay, that means the encryption algorithm will take 1 bytes at a time and it will convert, it will encrypt. But in block cipher, it is going to take it as a block. Okay, that means more than 1 byte. So how many, what is the size of the block means, it may change. It may change from one algorithm to another algorithm. In some algorithm, they will take 64 bits as a block. In some algorithm, 128 bits, they will take this as a block. So the block may change from one algorithm to another algorithm. Okay, so these are the 4 different concepts we are going to discuss. Now, if you understand DES, triple DES is going to be very easy. So what does that means? DES, it is going to operate, or it is going to work 3 times. 3 times it is going to operate. Okay, so it is going to be the triple DES. AES is a very important algorithm. Many of the applications, starting from Wi-Fi network, okay, there are plenty of algorithms available, applications available where the AES is used. Okay, AES is a very popular algorithm nowadays, symmetric key encryption algorithm, and it is used in many of the applications. In many applications, okay, we are using this. Now, so this is the a small introduction. That means what we are going to study in this particular lecture. Now, let me go to the first one, DES, data encryption standard algorithm. Okay, so this is the algorithm. Okay, now what I'm doing means, I'm going to take a text. So this is my plain text. Hello is my plain text. So the plain text, I'm going to send into the algorithm. Okay, into the DES algorithm. Okay, I'm going to send it into the DES algorithm. Okay, now this is the DES algorithm. You can see. So this is the DES algorithm. So I'm having a DES algorithm here. So inside the DES algorithm, I'm going to send a message. Okay, so this is the DES algorithm. So the message, I'm going to pass it into the DES algorithm. You need a key. Okay, there should be a key. We need a key for this. Okay, I'm going to pass a key. I'm going to give a key for this. Then the output is going to be, okay, it is going to generate the cipher text. Okay, the output, what is going to come means, I'm going to get a cipher text from this. Now, this DES algorithm, how it works? Okay, how it works. What are the things happening in this algorithm? Okay, what are the things happening here? So this is, okay, we are going to study, okay, here. How does a DES algorithm is working? Okay, this is what we are going to study. Now, I'm going for the basic points, the important basic points about this DES. Okay, DES is a symmetric key block cipher algorithm. So we already know this. It is a symmetric encryption and it is a block cipher encryption, block cipher algorithm. Okay, symmetric means it is going to use only one key. Okay, only one key it is going to use. That means the same key will be used for encryption and also for decryption. Then it is a block cipher. This is a very important point. So what is a block cipher? Here they are going to take from the plain text, they are going to take the blocks. Okay, they are going to take the blocks and they are going to convert it. Then the next question is, what is the size of the block? Okay, these are all multiple choice question. Okay, what is the size of the block? Okay, what is the size of the block? So the size of the block is, okay, the size of the block is going to be 64-bit is going to be the block size. Okay, the block size is 64 bits. So you have to keep all these things in your mind, okay, because these are all the basic points, technical points. So DES is a symmetric key encryption. DES is a block cipher algorithm. Okay, the size of the block, the default size of the block is 64 bits. 64 bits is a default block size. Then it is going to use a key. Without key, there is nothing going to happen here. Yesterday class, we discussed about the key, public key of bank musket. What is the length of the public key means? Bank musket public key length is 2048 bits. 2048 bits is the length of the public key of bank musket. So here in this algorithm, what is the size of the key? What is the length of the key? That is also very important. So the length of the key is 64 bits is the length of the key. Okay, the length of the key is going to be 64 bits. The size of the block is also 64 bits. Then in the 64 bits, that means in the key 64 bits, we are going to say 56 bits are effective key length. It is the 56 bits we are going to say it is effective. The remaining 8 bits, about this we are going to discuss it later, okay, in the coming slides. 56 bits will be very effectively used. 8 bits of the 64 bits are not used. It is not used for encryption algorithm. So only 56 bits, it is an effective key. The remaining 8 bits is not going to be used, but these 8 bits are going to use as a check bits. It is going to use as a check bits. What is that? We will discuss it later. Okay, so it is going to use 64 bits of key. Effective key means only 56 bits. The remaining 8 bits will be used as a check bits. What is check bits? We will discuss it later. Then the next important point, DES algorithm is going to take 16 rounds. It is going to work. It is going to work. How many rounds it is going to execute? Rounds means like loop. So how many loops we are going to see in the next slide. So how many rounds it is going to work means it is going to work 16 rounds it is going to work. Okay, it is. So 16 rounds. So technical points. These are all technical things. So I repeat the points. DES is a symmetric key encryption. DES is a block cipher. The block size of the block is 64 bits. The length of the key is 64 bits. Effective key length is 56, and 8 bits are used only for the check bits. It is used as a check bits, and it is going to work 16 rounds. It is going to work. So these are the important points. Then there are some more points available. This is published by NIST, National Institute of Standards and Technology, okay, from US. This is an organization, standards organization. So they publish this. And then the design is an implementation of Feistel Cipher. This is a very popular encryption technique. So based on that, they designed this. Okay, the DES is designed. Okay, that's not a very important point. Okay, but technical points, I already told that are the very important points. Okay, now let me go to the next slide. You can see how the DES is going to work. Now, the DES algorithm, okay, so this is the block diagram of a DES encryption algorithm. Okay, how it is working. Now, you can see here 64 bits of plain text it is going to take. This is called block. Okay, if I have a message, okay, a very big message, my message plain text will be converted into blocks. 64 bit, 64 bit, 64 bit, 64 bit. It will be converted into blocks. Now, I'm taking the first block. This is block number 1. So you will be having 2 blocks, 3 blocks, 4 blocks, even 10 blocks, 100 blocks. Okay, it is not an issue. So now I'm going to take the first block. Okay, 1 block of data I'm taking. So the size of the block is 64 bits is the size of the block. Okay, so I have taken 1 block here. Then, okay, algorithm starts. What this algorithm is going to do, now you can see, I'm going to send this 64 into initial permutation. So permutation means I'm going to change the place. That means first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, up to 64 bits available. So the 64 bits, we are going to change the place. So about initial permutation, how the initial permutation is working, we will see it later. But initial permutation means all the places, the bits will be shuffled. Okay, I'm taking all the 64 names of the students. First student, second student, third student, fourth student. I'm going to put it in a box. I'm going to shuffle it. Okay, I'm going to shuffle it. So initial permutation means simply changing the positions. Okay, first bit will go some place. Second bit will go to the some other place. Okay, third bit. Okay, I'm telling example. First bit will go to the 30th place. Second bit will go to the 15th place. Third bit will go to the 64th place. Okay, fourth bit will go to the second position. So they will change the position of the bits. Okay, that is called the initial permutation. So step number 1, what is that? Initial permutation. Okay, after initial permutation, it is going to start the rounds. Okay, how many rounds it is going to work? We already discussed in the previous slide. It is going to work for 16 rounds. It is going to work. Then round 1, round 2, round 3, round 4, round 5, round 6, rounds. Okay, up to 16 rounds it is going. Then first round, okay, you see the round output. The output of the first round will be used as the input for the second round. So the output of the second round, it will be used as the input for the third round. Okay, the output of the third round will be used as the input for the fourth round. So it is going on to continue like that. Now, what is going on inside the round, we will see it later. Okay, what is happening in round? Okay, only one round if you study it is enough, because in all the rounds, the same thing is going to happen. Then finally, after the 16th round, it is going for the final permutation. Here, initial permutation, okay, changing the position. Now, again, it is going to change the position. So first bit will be placed somewhere. Second bit will be changed to somewhere. Third bit, okay, different position. So they are going to change the complete position. They are going to change. Then finally, whatever you are going to get, that is going to be your ciphertext. So how does a DES is working means? It is very simple. Taking the 64 bit of plain text, apply the initial permutation, then go for the round function, round 1, round 2, round 3, round 16, final permutation, and finally the cipher. That means the ciphertext is generated. Okay, now you can come to the key. So in the key, what is happening means, we are giving the key. In the last slide we discussed, 64 bits is the size of the key. The 64-bit key, we are going to use only 56 out of 64. Only 56 key will be used as effective keys. Okay, now I'm taking 56. Now you can see here, from this 56, I'm going to generate randomly. I'm going to generate the keys 48 bits randomly. I'm selecting all the 56 I'm not using. From the 56 randomly we are going to generate 48-bit key. We are going to generate 56 is available. It is very good. From that I'm doing something. and I'm going to generate, okay, the round key, that is called the round. So for every round, a different 48 will be taken from this 56. So this is the first key, second key, third key, fourth key. So 16 different keys I'm going to generate from this 56-bit keys. So every key will be used for the different rounds. Okay, so what is happening inside the round, we will see it later. So this is how the DES is working. Okay, so please can you summarize? Okay, can you summarize how does DES algorithm works? Okay, let me summarize. Okay, I'm going to summarize. Please listen. Very simple. What is that? Take the data or convert the data into 64-bit blocks. This is point number 1. Convert your data into 64 bits of data. Okay, that is going to be the blocks. Then take the first block and apply it into the permutation. This is step number 2. Once permutations is over, once you have done the permutation is nothing, just changing the position. So once the permutation is over, now we are going to generate the round keys. 64 bits, okay, third point, generate the round keys. 56-bit key is the effective. From the 56, 16 different keys, 48-bit keys will be generated. Then every key will be used as the input for the every round. Totally 16 rounds will be taking place. For every round, we are going to use a different, okay, 48-bit key. Then we are going for the final permutation. So after the final permutation, again permutation means changing the position. So after permutation, whatever you are getting, that is going to be your ciphertext. So this is how we are going to, okay, that means the DES is going to work. Now, let me go to the next slide. In the next slide, we are going for the initial and final permutation. So what is happening in the permutation? I already told. Teacher, is it necessary to memorize this? Means no need to memorize. No need to memorize. But what is this means? You must understand the concept. You must understand the concept. Okay, nobody is going to ask you to write, okay, the structure of initial permutation, the structure of final, no, but they may ask you to draw this diagram. Okay, draw the block diagram of DES, how DES is working, and explain the steps. Okay, that is okay. Now you can see here, this is the initial permutation and final permutation. Okay, now what is the initial permutation means? Changing the position. You see 64 bits of data, first bit, second bit, third bit, fourth bit, 8th bit, 25th bit, 40th bit, 58, 64. Now the first bit, okay, that means the data available in the first bit, okay, either 0 or 1, okay, because this is binary, 0 or 1. So now whatever available in the first bit, I'm going to move it to the 40th bit. Then whatever available in the second position, I'm going to move it to the 8th position. So the data available, the bit, the value available in 58, I'm going to move it to the first position. Then the data available here, okay, that means in 64, I'm going to move it to 25. So this is called the initial permutation. So initial permutation means just you are going to swap, you are going to change the position of the bits. Okay, so this is going to be the initial permutation. Then after initial permutation, you can see 16 rounds going. Now I'm going for the final permutation. Okay, the final permutation, you can see what is happening. The same thing, whatever available in the first position, the value available in the first position, I'm going to move it to the 58th position. Then the value available in the 8th position, I'm going to move it to the second position. Then the value available in the 5th position, so it will be moved, okay, it will be moved to the 64th. So value available in the 40, okay, whatever, either 0 or 1, which is available in the 40, we are going to move it to the first position. So this is going to be the final permutation. We are doing the final permutation in this. Okay, now you can ask a question. Teacher, can I change this from 1 to 40? Can I change it from 1 to 48 means? No, you cannot. Because these positions are already fixed. They fixed in the algorithm. Okay, in the DES algorithm, they already fixed this. So we cannot change this. Okay, you should not change this. You have to follow this. So initial permutation means what? Final permutation means what? You have to understand that concept. Okay, so changing the bit position according to some formula. So this is already fixed. It is already fixed. Okay, we should not change the place. So 1 to 40 means it should go 1 to 40. 2 to 8 means it should go only from the second to 8. Whatever the data, the bit available in 58, okay, we have to move it to the first position. Whatever the bit available in the 64, move it to the 25. So this is going to be the initial and final permutation. Okay, now go to the previous diagram. So you will understand. So 64 bits plain text we are taking. So initial permutation we studied, we completed, and final permutation we completed. Now, next one. The next very important thing is, so we are going for the rounds. Okay, now I'm going for the round function. This round function is very important. Okay, you will be asked to draw the round function. Round function is very important. Now, what is a round function? What is going on inside the round function means, before that, the round function is 16 rounds. That means we are going to repeat this 16 times. This will be repeated 16 times. It will be repeated. Very good. What is the input for this round function means? The input is, okay, you can see the input is, okay, 64 bits, or it is from the previous round. For round 1, initial permutation, but for round 2, it is from the previous round. Okay, that means the output of the round 1 will be used for the, okay, as the input here. Okay, very simple. For a round function, the input is going to be the output of the previous round plus key. So there are two inputs available. Okay, there are two inputs available. Okay, now I'm just going for the round function. So this is the round function. So round function is very important. You have to draw this and you have to keep in your mind. Now, what is round function means? This is going to be the heart of DES. So this is the main thing. Okay, now in this you can see applies 46-bit key to the rightmost 32 bits to produce the 32 bit of output. Okay, what is that? See, your key size. What is the size of the key means? The size of the key is 48 bits. This is what we saw in the previous slide. Round key. Okay, if you want, I'll go to the slide number 1. You can see here. So from the 56, you are taking 48 bits you are taking. So the input key, K is the key, 48 bits is the input. So 48 bits is coming. Okay, 48 bits is coming. Now you can see what is the input means. The input is 64 bits of data. 64 bits, that means the block. The block is the input. Okay, now what I'm doing means the block I'm going to, okay, listen carefully because we are not using the boards. Okay, this is the drawback. So please careful. See here, what is the input means 64 bits of data is going to come. This is going to be the input. 64 bits of data after permutation or from the previous round, no problem. So this is going to be the data. 64 bits of data is the input. Now, this 64 bits of data, I'm going to divide into two. I'm going to divide into two parts. I'm going to divide into 32 bits plus 32 bits. That means I'm dividing into left and right. So 32 bits, this is going to be the left. Then this 32 bits, I'm going to consider this is the rightmost part, or okay, which is available towards your right. I'm dividing into two parts. 32 bits, 32 bits. Now, the next step, what I'm doing means, you can see, I take only the rightmost 32 bits I'm taking. Teacher, what happened to the left 32? Left 32, I'm not going to touch. Okay, I'm taking only the right. So right side 32 bits only I'm going to take. Now, so 32 bits of data I'm taking. But if you see the key is 48 bits is the key. 48 is the key. But here I have 32 bits of data. So these two things is not matching. 32 bits of data, 48 bits of key. So these two things not going to match. So what I'm going to do, this 32 bit, I'm going to convert, I'm going to expand. So this is called expansion box. I'm going to expand. So what is available inside the expansion box? It is given. It is given in the next slide, but we no need to memorize that. Now, so expansion box, I'm sending it into the expansion box. The expansion box is going to convert this 32 into 48 bits. Okay, it is converting, okay, into 48 bits. Now, so this is the 48 bits and my key is 48 bits. I'm going to apply exclusive OR operation. You might have studied about AND or NOT. Same like that, exclusive OR operation. So what is exclusive OR operation means? A, B bar plus B, A bar. Okay, that means you might have studied this, okay, exclusive OR operation, but if you are not understanding, no problem. I will solve it later. So it is going to apply exclusive OR operation here. Now, exclusive OR operation, if you apply, okay, like AND or NOT, okay, AND operation, OR operation, okay, in the computer organization course, you might have studied about it. Now, so I'm going to apply the exclusive OR operation, and whatever the final output, it is going to be the 48 bits output. Now, okay, just imagine, okay, you have to think about it, then only you will get it. So 64 bits of data I'm getting. I'm dividing the 64 bits of data into two parts, left and right, 32 bits, 32 bits. So leftmost 32, I'm not doing anything, just keep it. Go to the rightmost. So the rightmost is only 32 bits. You have to convert into 48 bits. You're converting into 48 bits by using an expansion box. Then, after converting into 48 bits, I'm going to apply the exclusive OR operation. Exclusive OR operation I'm going to apply for both K1 and your data. That means this 48 bits, and final output I'm going to take. Then, now, this is 48 bits. The output is 48 bits. Again, this 48 bits should be converted into 32 bits. Okay, it should be converted into 32 bits. Now I'm going to use a concept called S box. So using the X box concept, so what I'm doing means I'm going to convert this 48 bits into 32 bits. So this X box also, okay, we are going to see it in the coming slides, and that is also you no need to memorize. Okay, so expansion box also available. We no need to memorize about it, how the expansion is going on. Okay, there is some, okay, diagram is available for that. But this is very important. The round function is very important. So 48 bits of data available, output after the exclusive OR. Okay, so I want to convert this 48 into 32 bits. I want to convert into 32 bits. So I'm sending it into the X box. So S box is going to convert this into the 32 bits. Then, okay, what is straight P box? We will see it later. Now, so 32 bit is output. Already this side you have 32 bit. So that is going to be 32 plus 32, 64 bit. So 64 bit is now the output for the next round. Okay, so it is going to the next round. So in the next round, again, you will divide into 32 bit, apply to the expansion, find the exclusive OR operation, apply the S box, apply the straight P box, and again output. So like this, it will be repeated 16 times. It will be repeated. Okay, it will be repeated. Now I go to the first diagram, block diagram. You will understand. Okay, clearly now. See, taking the 64-bit data, applying the initial permutation, again 64 bits here, converting the 64 bits into two parts, 32, 32. So 32 is going inside the round 1. 32, I'm converting into 48. Then this is the 48. For both, I'm going to apply the exclusive OR operation. Then I'm going to again convert the 48 into 32. Now the 32 in your left, 32 on your right. So totally 64 bits. Again, it is going as the input for the next round. So in the next round, we are going to divide like that. Okay, again, we are going to do it. So we are going to do the process, same process. We are going to repeat 16 different times. We are going to repeat. Then finally, you are going to apply the final permutation and you are going to get the cipher text. So This is how, okay, your algorithm, that means the DES algorithm is working. Okay, now I go to the round function. We will see this expansion and S box. Okay, we will see this. Okay, now let me go to the next one. You can see expansion box. So what is the expansion box? Try to understand the concept. No need to memorize this, okay, because this is already fixed by this algorithm. Okay, so in the algorithm, while writing the algorithm itself, they fix this. So we no need to memorize this, okay, but you have to understand this. Okay, now what is this? Expansion. What is expansion? 32-bit of data is available. Okay, that is the rightmost, right side, left side 32 bits, right side 32 bits. You are taking the right side 32 bits. Your round key is 48 bits. So these two things are not matching. To apply, okay, to apply the exclusive OR operation. So what we are going to do, I'm going to have a expansion. I'm going to expand this as a 48 bits. Okay, I'm going to expand this as a 48. How you can expand? You can see. This is the method. What is that? See, 32 bits. Okay, we are dividing into 1, 2, 3, 4, 5, 6, 7, 8. I'm dividing into 8 parts. Okay, I'm dividing into 8 parts. So 8 parts means 8 into 4. Okay, 8 into 4. So it is going to be 8 into 4. It is going to be 32. Now, see, now I divided this into 4 parts. You can see here. On first position, I take as it is. I'm not doing any change. Second position, I'm taking as it is. Third position, fourth position, I'm taking. Now, what is the fifth position means? You can see whatever available in this place, I'm going to use this as the fifth position. Okay, this is called expanding. They want to expand this as 48 bits. Okay, see, first one. Okay, no need to worry about it. Leave it. Okay, the second one, I'm taking as it is. Taking as it is. Okay, take the bit as it is. So whatever the value available here, I'm going to take. The next one, I'm going to add. Okay, if I add whatever the value available here, I'm going to push it here. So now what is happening? 1, 2, 3, 4. 4 bits is now becoming 6 bits. So this bit, I'm going to take it from the last bit. The last bit I'm going to take from here and I'm going to insert here. So this is how the expansion is going on. Okay, we are going to expand the bits. Now you see, if you go for the third position, okay, first bit, second bit, third bit, fourth bit. There are 4 bits available here. I'm taking the first bit, I'm taking the second bit, third bit, fourth bit. I want to expand. I want to add 2 bits. So this bit, from where it is coming? From the previous 4 bits, the last bit I'm taking and I'm going to place it here. And here what I'm doing, I'm going to take here, okay, from here and I'm going to insert here. So this is how you can expand this. Okay, so this is how the expansion is going on. So finally what will happen? Your 32 bit will come, okay, it will become as 48 bits. Okay, so this is, okay, how the expansion is working. Okay, now you can see exclusive OR. So exclusive OR operation, it is, okay, 2 things. Okay, we will see the exclusive OR operation. I will show it to you later. Okay, just wait. Now, going for the next one, substitution box. So what is a substitution box means? The substitution box is going to reduce. Okay, substitution box is going to reduce. So you have 48 bits. The 48 bits should be converted into 32 bits. Okay, it should be converted into 32 bits. So how can I convert means? I can use this concept. So this concept is called S-box concept. Okay, now you can see. So totally 48 bits available. So 1, 2, 3, 4, 5, 6. So I'm dividing 6 bits. How many parts? 1, 2, 3, 4, 5, 6, 7, 8. So 8 parts I'm dividing. So 6 into 8, 48. Now I'm going to have a X box here. This X box is going to reduce. It is going to reduce the number of bits. So the 6 bits will be converted into 4 bits. In the previous slide, we discussed about the expansion. How the 4 bits will be expanded to 6 bits. So here the 6 bits will be minimized. It will be reduced. Okay, it will be reduced. So each S box, this is called the S box, or we can say substitution box. So this box is going to take 6 bits of output. It is going to reduce it. Then it is going to produce 4 bits. The 4 bits of output it is going to produce. Now you can see what is S box. The S box is going to work like this. It is going to work like this. Okay, what is that? You see 1, 2, 3, 4, 5, 6. 6 bits it is taking. Okay, 6 bits it is taking. Then, so the S box operation is going on. And finally, what it is happening means only the 4 bits it is going to produce, only 4 bits it is going to produce. Okay, it is going to produce only the 4 bits. So, S box, it is going to reduce the bits. Okay, expansion box is going to increase. Okay, it is going to increase the, okay, that means the bits will be increased. Okay, now you go to this function, you will understand now. See, 64 bits of data is coming. We are dividing the 64 bits of data into 2 parts, 32 bits, 32 bits. Now, I'm taking the rightmost 32 bits. I'm applying into the expansion box. So the expansion box is going to make it into 48 bits. It is going to expand. We already saw that, how it is happening. Then I got 48 bits, I got. Then key, I have the key. So the key is coming here. So using the key, okay, and my expansion, I'm going to apply the exclusive OR operation. Okay, I'm going to apply the exclusive OR operation. So the final output is going to be 48 bits. So 48 bits, I want to convert into 32 bits. I'm going to use the S box. So each S box, it is going to take 6 bits of input, and it is going to reduce that 6 bits into 4 bits. It is going to convert into 4 bits. So the S box is going to reduce the number of bits. Okay, it is going to reduce the number of bits. So I'm just reducing the number of bits. Okay, so the bits are reduced, and then finally I'm taking the 32 bits I'm getting. Okay, then the last one is after this we are going for something called straight permutation box. So what is straight permutation box means? Okay, you can see here. Okay, the straight permutation box is, okay, so 32 bit of output. So S box then subject to the straight permutation. What is the straight permutation means? This is the position. That means the first bit, whatever the first bit coming from here, it will be placed in the 16th bit. The second bit, whatever coming, okay, this is also you no need to memorize. Okay, just know the steps. Okay, just know the steps. So straight permutation means the first bit. Okay, okay, I repeat the point. So here you are going to get the 32 bits. So this 32 bits, you are going to change the position, place. So the first bit, okay, it will be sent to some place. So the 16th bit, it is going to come here. The 7th bit, you are going to take it as the first. 20th bit, you are going to keep it in the 3rd place. 21st bit, you are going to keep it in the 4th place. So this is called the straight permutation. Again, I'm telling what is permutation means changing the position. That's it. Changing the position. We are going to change the particular position. Okay. So now you can see, just you will summarize everything. Let me summarize everything. Okay. See, initial permutation, final permutation, we already studied. So what is initial permutation? Changing the position. What is the final permutation? Changing the position. Then go to the round. What is happening in the round? In the round, we are taking only 32 bits. We are sending into expansion, convert into 48. Then 48, we are going to apply the exclusive OR operation with the 48 bits of key. The output is 48. Now the 48 should be converted into, again it should be converted into 32. We are using S box. So for the purpose, we are using the S box. From the S box, whatever the output it comes, we are going to send it into another permutation. That is called the straight permutation. Okay, that is called the straight permutation. So apply it into the straight permutation, and okay, the output is going to the next round. So this is how this algorithm is working. So you are just listening, okay, you are listening to this concept first time. So you may feel difficult, but if you ask me, okay, how this is working, I can tell in 2 minutes. Yes. So in the state permutation box, so state permutation box, what it is going to do means it is going to change the place. Okay, that means the 16th bit, okay, it will be placed as the first bit. The 7th bit, it is going to be placed as the second bit. The 20th bit, it will be placed as the third bit. Okay, it is going on like that. So this is going to be the state permutation. Now you can see after completing the state permutation, we are going to get the, okay, we are going to get the output. The output is going to be the 32 bits. Okay, 32 bits. Okay, now we are going for the next round. We have to go. Okay, what it will happen means here they will swap the bits. That means the left will come to the right, right will go to the left. Okay, 32 bits, they will make the left and right, they will swap. Swap means, okay, left will go to the right side, right will go to the left side, then it will go to the next round. In the next round, okay, it will be repeated. It will be repeated, same like this, it will be repeated. So you will get 32 bits and here 32 bits will be available. Then you will be swapping. So that means this 32 bit will become the left and here, okay, it will become the right. So automatically what is happening means 16 times if you run, 8 times, okay, the left side, 8 times the right side, okay, you are going to apply the DES function. The round function will be applied. So finally, whatever you are going to get, that is going to be your ciphertext. Now, I already told, okay, what is the exclusive OR? Okay, what is exclusive OR function? I'm going very slow because I need you to understand. Okay, this is one of the very biggest lecture, okay, in our course. Lecture number 3, if you complete, most of the things is over. Now, so I'm going for the exclusive OR operation. So what is exclusive OR operation? How the exclusive OR operation will work or how it looks means the exclusive OR operation is equal to A B bar plus A bar B. Okay, let me insert the truth table here. So I want you to understand. That's why I'm just inserting the truth table of exclusive OR operation. You can see this is an exclusive OR operation. Can you see the screen? Can you see it?
Yes.
Are you able to see the truth table, exclusive OR truth table? Please repeat.
Yes.
See, this is exclusive OR. What is exclusive OR means? Okay, that means the result is equal to A B bar plus A bar B. Okay, this part we are going to do it in our lab part. Okay, we are going to do this. We are going to solve some problems. Okay, based on that in lab. Okay, so you don't need to worry about this too much now. So see, if both the inputs are same, 0 0. If both the inputs are same, the output is going to be the 0. If both the inputs are different, the output is going to be 1. Okay, so 0 0 means 0, 1 1 means 0. So 1 0 1 0 1 is 1. So this is the exclusive OR operation. So you might have studied about this in computer organization course. Okay, this is about the exclusive OR operation. Now, so I think you understand the overall idea, you got it. Okay, now the last one we have to see is the round key generation. How this 56-bit is converted. Okay, how the 56-bit is converted into a 48-bit. Okay, so this is going to be the key generation part. So that is also easy one. Already we studied a lot of concepts. So the same concept will be repeated. Okay, now you can see here. So what we are doing means we are going for the key generation. This key generation separate. Okay, it is a short answer question. Explain the key generation concept of DES algorithm. Okay, so once if you complete the key generation, the DES will be over. Now I'm going for the key generation. How the key will be generated? It is going to generate 16 different keys. It is going to generate. Okay, now you see here 64-bit of key we are going to take. We already discussed in that 64-bit only, and we are going to use 56. 8 bits we are not going to use it. We use it for checking some other purpose. Okay, now we are taking only 56 bits of key we are taking. 56-bit key. Okay, we are taking again the same concept. I'm going to divide this 56 into two parts. Same like our DES. I'm dividing into two parts. One is 28, another 28. So 28 is on your left and 28 on your right. Okay, it is available. I'm dividing this into 28, 28. Okay, now from this 28, 28. So 28, 28 is 56. So from this 56, I want to take only 48. So what you have to do? You have to go for the compression. You have to reduce it. Okay, you have to reduce it. Okay, now you see, I'm doing shift left, shift left. What is shift left means? One bit will be shifted left side. Okay, towards your left, one bit will be shifted. Okay, shifting means moving. So shift, okay, it will do. Then the 28 bits, okay, it is going to be 56. 56 will be compressed. Compressed means it is going to be reduced. How it is reduced? We are not seeing that. So it is reduced and I'm going to get 48 bits. Then the next again one bit will be shifted. It will be shifted. Shifting means 101 means it will be shifting. Okay, one bit will move. So again it is going to shift and again it is sending into the compression box. Okay, and 48 bits is coming. So this will be repeated. Okay, it will be repeated 16 times. So we are going to get 16 different keys we are going to get. Okay, there is nothing available here. Okay, let me repeat. Take the 64-bit key. Last 8 bits is not used, so 56. So 56 is divided into two parts. We are going to divide into two parts. One is the left and right. Okay, then we are going to do shifting. Shifting means, okay, we are going to move one bit towards the left. Okay, towards left, you are going to move one bit. Then send it into the compression box. So the compression box is going to reduce the 56 into 48 bits. That is your first round. Second round, again you have to shift one bit. Okay, so shifting one bit. Okay, if you want to know a very simple shifting, I will do it here. Then only you will understand. See, 1 1 0 1. This is 4 bits. I want to shift left. Okay, so if I shift left, okay, you can see this one. Okay, this one will become the first. See the screen. This one will become the first. One bit we have to shift. So 1 0 1 1. It will become like this. Shifting left. Now again I want to shift one bit. 0 1 1. So the last one will come. Okay, the first one will become, again it will become as next one. This is shifting. I want to again shift. 1 1 1. 0 will come in the end. So this is called shifting. So they are going to shift and then, okay, every time they will shift one bit they will shift, and finally, okay, they will send it into the P box. So the P box, that means the permutation box, or we can say it is a compression. Compression means reduction, reducing. It is almost like S box. We already discussed about the S box. So it is going to summarize. Okay, it is going to make it into less. That means 56 bit will be converted into 48 bits. So this is how the things is going to be repeated. And finally, okay, we are going for the final compression. So this is how, okay, your DES is working. So if you see from the first time if you see, you may feel something it is very big, but it is not going to be a very difficult concept. Okay, just you must know the overall process. You must know. Okay, now I'm going for the next one. The next one is triple DES. So the triple DES, okay, what is that means? Okay, we are not going to study too much about this. Only 2, 3 slides we are going to study. What is triple DES means? 3 times we are going to do the DES. 3 times. Triple DES means 3 times if you use this DES, it will come triple DES. That's it. That's it. Okay. So you take the data, first apply into the DES algorithm, you will get a cipher text. Then apply into the Cipher, the DES algorithm, you are going to get some output. Again, you are going to convert, okay, you are going to enter, but small change, only one small change is that. Let me tell what is that. Okay, now I'm going for the second algorithm, the second concept in this lecture. It is the triple DES. Okay, what is triple DES means? So this is a modified scheme. The modified schemes of triple DES, that means sometimes known as 3 DES. Okay, we can say the DES 3 times. Okay, there are two variants of triple DES. In triple DES, they are having two different methods. The two variants of triple DES. Okay, what are they? One is 3-key triple DES and 2-key triple DES. Okay, what is that? We will see. Okay, so 2-key triple DES and 3-key triple DES is available. Okay, now we are going for 3-key. Okay, only one I think we will study, not both. Okay, now I'm going for the triple key, 3-key. 3-key DES. Okay, 3-key triple DES. Okay, what is this means? Now you can see the algorithm here. Okay, see, this is my data, 64-bit of data. I'm going to send it into the DES. Okay, I'm going to send it into the DES algorithm. Okay, this is what we studied in the previous slide. Okay, from slide number 1 to slide number 13, we discussed about this, how it is working. There are 16 rounds available in that. So in each round, okay, what is happening? Okay, it is going to convert the 32-bit into 48-bit exclusive OR operation. After that, okay, we are going to reduce it. Then you are going to use the direct permutation. So all these things happening here. Okay, all these things happening here. Then whatever the output I'm going to get, I'm going to use, okay, the same DES. This is the reverse cipher. I'm going to do it. Reverse cipher means, okay, encryption to decryption. I'm going to do it. Then again, I'm going to encrypt the data. Okay, you can see 3 times. This is 1, this is 2, this is 3. So 3 times you are going to apply, okay, the DES function. Okay, and finally, whatever you are going to get, that is going to be your ciphertext. So here, 3 different keys will be used. K1, K2, K3. 3 different keys will be used. So this is going to be 3-key triple DES. K1 is a different key. K2 is a different key. K3 is a different key. So 3 different keys will be used. Okay, just think, teacher, you are doing encryption. Okay, whatever I'm getting is the ciphertext. The ciphertext, I'm going to do the reverse. Reverse means I'm going to decrypt. Okay, I'm going to decrypt. Can anyone answer this? Okay, please answer this. Okay, let me check. I'm just giving an example. Okay, I'm giving an example here. See here. This is my plain text. 1, 2, 3, 4 is the plain text. 64-bit plain text. Now, after encryption, please, okay, I need answer from someone. Okay, let me see. Okay, after decryption, sorry, encryption, after the first round, I'm going to get the value. Okay, for example, so this is going to be my ciphertext. Let it be A, B, C, D is my ciphertext. Okay, so this is my ciphertext. A, B, C, D is my ciphertext. Now, again, I'm going to decrypt it. If I decrypt here, what will be the output here? What is the output expected here? Here, what will be the output? Do you understand what I'm asking? Shall I repeat my question?
Yes, Mr.
See, 1, 2, 3, 4. Okay, this is my plain text. My plain text. I'm going to encrypt. I'm going to apply encryption. I'm going to encrypt it. I'm going to get A, B, C, D. This is my ciphertext. Now, this ciphertext, I'm going to send inside. I'm going to send it inside, okay, the reverse. Reverse means decryption. I'm going to decrypt it. This is encryption. I have done decryption. So if I have done encryption here. This is encryption. I'm going to do decryption here. If I do decrypt, what is the output I will get? What will be the output I will get? Will I get 1, 2, 3, 4 here? Or will get something different? Try to understand my question. See, What is encryption? You can convert the plain text into ciphertext. Okay, this is plain text converted into ciphertext. What is decryption? You can convert the ciphertext into plain text. Convert the ciphertext into plain text. That is decryption. Now answer my question. In this case, what will be the output? You will get 1, 2, 3, 4, or you will get a different answer.
1, 2, 3, 4.
1, 2, 3, 4.
Okay, 1, 2, 3, 4. 1, 2, 3, 4. Very good. See, if you get 1, 2, 3, 4, what is the use of this? If you get one, okay, just think. Just think. If you get 1, 2, 3, 4, what will be the use? What is the use of this? It is unnecessary. Okay, that is the place. That is the place you have to think. Okay, you are giving answer. 1, 2, 3, 4 should come. It is correct. But 1, 2, 3, 4 is coming means what is the use of this? So you are just doing encryption, then you are doing decryption. No use. So, but what is that means? You see, a different key is used. That is the concept here. They are using a different key here. They are not using the same key. If you use the same key, okay, you will get, okay, you will get the answer. But this is not the same key. They are going to send, okay, they are going to use a different key. They are going to use it in this place. Okay, you can see K2. If you use K1 here, you will get 1, 2, 3, 4. You will get 1, 2, 3, 4. But okay, because for encryption, I'm using K1. If I use the same key here, K1, if I use the same answer, you will get 1, 2, 3, 4, you will get. But I'm not using the same key. I'm using a different key I'm using. So if I use a different key, automatically you are going to get a different answer you are going to get. You are not going to get the plain text. So there will be something different is going to come. Then, so this one you are going to again encrypt by using, okay, the another key. So this is the encryption process. So 3 times we are going to use DES. First one is the encryption. Second one is the decryption. Third one is the encryption. Now go to the, this is encryption process. Go to the decryption process. What is the decryption? This is going to be the reverse. So 2 times you have to use the decryption. Okay, you can see this is the process. Same to this, it is going to be the opposite. Okay, what is that? You are getting the ciphertext. This is the ciphertext. The ciphertext is going from here. You can follow the mouse. Okay, you can follow the mouse. See, I got the ciphertext here. The ciphertext, I'm going to send it here. Okay, I'm going to send the ciphertext here. So the ciphertext is going here. Now, whatever the process you are, the same process, the reverse process. So first you use the cipher. So I use reverse cipher. Here reverse cipher, I'm going to use cipher. And here it is cipher, it is going to be the reverse cipher. So I'm going to do it everything in the reverse. So automatically your plain text, okay, you are going to get. So this is called triple DES. So people thought DES is not enough. Okay, DES is not enough. So we'll go for triple DES. We'll do it 3 times so that our data will be very strong. Okay, so this is the concept of, okay, the triple DES concept. Okay, now, so this is some advantage also available, disadvantages also available. But if you see, okay, advantages is more. Okay, advantages is more. So many applications, they are using the triple DES. Triple DES is using. So they're explaining how the triple DES is working. They're explaining encrypt, decrypt, encrypt. You can say encrypt, decrypt, encrypt. But different keys. K1, K2, K3. Okay, if you use same key, problem. You have to use different keys. Okay, this is the major concept. And this algorithm, if you see the disadvantage of this algorithm, it is slow. This algorithm is going to be very slow because you have to do it. Okay, here 16 rounds, here 16 rounds, here again 16 rounds. Okay, you just count how many number of rounds it is happening. So it is going to be a time consuming process. Okay, so it is going to be a slow. Okay, you can see clearly a much slower process than the DES. Okay, so this is more secure, but it is a more secured one. Okay, it is going to be more secure, but it is going to be very slow comparing with the previous methods. Okay, so this is about the DES. Okay, so I'll stop it today. In the last class, we discussed about the DES, Data Encryption Standard, and also we discussed about the Triple Data Encryption Standard, Triple DES. Okay, these are the two algorithms we discussed in the last class. Now, today we have another two more algorithms. So the first one is a AES, Advanced Encryption Standard. Then we have some block cipher modes of operation. Some modes of operations we are going to discuss. Okay, so these are the two topics we have to discuss in this particular lecture. Now, let me go to the ADS, Advanced Encryption Standard. Now, Advanced Encryption Standard is a very popular symmetric key encryption algorithm. It's a very popular algorithm. In many places, okay, you can see, okay, you can find AES, Advanced Encryption Standard algorithm is in use. There are so many places. Even if you have a wireless router in your home, you can check your wireless router, what is the encryption method they are using. Means most of the wireless access points or the wireless routers, they use AES algorithm for encrypting the data. So in many places, the AES algorithm is used. Okay, now let me start. So this is a very popular and also a widely adapted, widely used symmetric encryption algorithm. And this is 6 times faster than the triple DES. Last class we discussed about the DES. Then we discussed about the triple DES. So triple DES is 3 times stronger than DES. But if you see AES, AES is going to be 6 times faster than the triple DES. Then, and also the increasing the computing power, it is considered a vulnerable against the exhaustive key searching attack. It is very secured one. It is a very secured protocol. That means a secured algorithm. And here what is the problem means? The problem is the key. Exchanging the key is the problem. Not only for AES. Not only for AES. If you take any symmetric key encryption, the major issue is, okay, sharing the keys. Okay, we are going to use only one key for both encryption and decryption, and giving this key or exchanging this key, it is going to be a big issue in any symmetric key encryption. That is going to be the vulnerability here. Then, triple DES was designed to overcome this drawback, but it is slow. So that means we already discussed this point. DES is faster, but triple DES is going to be slow, okay, because it is going to do the same process 3 times. Okay, 3 times it is going to do. So the steps, okay, that means the points already we discussed in the last class. Now, I'm going for the AES. This is the very important thing. Please take it for multiple choice questions also. So the important features or the key features of AES algorithm. Okay, first thing, AES is a symmetric key encryption algorithm. Okay, this is point number 1. It is a symmetric key encryption algorithm. And it is going to be a block cipher. We know what is a block. So the data will be divided into blocks. So each block will be handled separately. So it is a block cipher algorithm. And here, 128 bit of data. That means the size of the block. The size of the block is going to be 128 bits. In DES, 64 bits. Okay, 64 bits, okay, in DES. So here we are taking 128 bits of data as a block size. Then we are using different key length here. There are different keys available. The key length is going to change. 128 keys, 192 keys, 256 bit keys. So the length of the key is going to vary from, okay, it is going to vary depending upon the application you can use. Okay, you can use depending upon the application. So there are 3 different variety. Okay, one is the 128, 192 and 256 is available. Then this is stronger and also faster than the triple DES. Provide full specification and design details. That means you can implement this in any programming language. You can write program for AES in anything. In C programming, you can write the program for AES. In Java programming language, you can implement. So in any programming language, you can implement this AES. Now, I'm going for the operations of AES. This is going to be the very important slide. How AES is going to work. Now, AES is an iterative. So iterative means it is going to have some loop. Yes, already we discussed in DES. DES is going to work 16 rounds. 16 different rounds it is going to work. So that is called the iterative. So here, okay, AES is going to be an iterative one. So that means it will be repeated. That means it is having some rounds. Okay, it is going to have some rounds. Then you have substitution, you have permutation. This is we already discussed in the DES. So what is substitution means? Okay, that means the substitution box. So permutation box. So there will be two different boxes will be available. So permutation means like changing the places. Substitution means replacing the things. So there will be a substitution and there will be a permutations. So the two boxes will be available. Okay, you can see what is permutation mean? Shuffling. Shuffling the bits. Shuffling the bits means moving the bits from one position to another position. From one first bit, okay, I move it to the 30th bit. Second bit, I'm going to move it to the second bit. So you can change, you can move it. So that is called the permutations. We have substitution. Substitution means one bit will be substituted. It will be replaced, replacing. It will be replaced with another bit. Okay, it will be replaced with another bit. So that is going to be the substitution. So substitutions will be available, permutations will be available. There. AES performs all its computations on bytes rather than bits. So it is going to consider only the bytes. That means minimum 8 bits. So it is not going to do bit by bit, but it is going to do byte by byte. Okay, because the size of the block is big. Okay, the size of the block is big. So any operations, it is going to do only byte by byte, not by bits. There. AES treats the 128 bit of plain text as a block as 16 bytes. That means 128 bit is the size of your block. You can divide into bytes. So if you divide into bytes, so automatically it is going to be 16 bytes of data. There. These 16 bytes are arranged in 4 columns, 4 rows. Okay, we are going to see the algorithm. Okay, we are going to see the algorithm. The 16 bytes of data will be arranged into 4 rows and 4 columns. It will be arranged as 4 rows and 4 columns. Okay, what is that? We will see it in the algorithm. There. The next one, you can see the number of rounds. We already told the number of rounds is going to change. It is going to change. Okay, sometimes if I want 10 rounds, you can have it. I want 12 rounds, you can have it. I want 14 rounds, you can have it. But in DES, it is fixed. The number of rounds is fixed in DES. 16 rounds means 16 rounds. You don't have any flexibility there. But here, it is not like that. Here, you can have different number of rounds, the iterations or the routes, that means the rounds may change. How? If you have 10 rounds, that means depending upon the key, okay, you say, if I used 128 bit key, 128 bits keys, you can go for 10 rounds. If you are having 192 bits of keys, okay, this is multiple choice question. Okay, this is a very important. 192 bit of keys means it will go for 12 rounds. If it is 256 bits of keys, if you are using 256 bit of keys, okay, 14 rounds. So depending upon the length of the key, this is the point. Depending upon the length of the key, the number of rounds is going to vary. It is going to change. Okay, so this is a very important thing. So if it is 128 bit key, it is going for 10 rounds. If it is 192 bit keys, okay, it is going for the 12 rounds. If it is 256 bit key, okay, it is 14 rounds. So you can use any option here. Okay, you can use any option here. Okay, this is. So this is how the things are working here. Each of these rounds use different 128-bit round key, which is calculated from the original AES. Okay, that means depending upon the key, okay, it is going to change. Now, I'm going for the next one. You can see this is the block diagram. The block diagram of AES, maybe. Okay, you'll get a question like this. Draw the block diagram of AES, Advanced Encryption Standard. Okay, and they explain. So this is the block diagram. So what is the block diagram? The block diagram shows, you can see, I have 128-bit key. This is the key. Depending upon the, you can change, you can increase or you can decrease the length of the keys. Okay, you can increase and you can decrease the length of the keys. Suppose if you are going for, okay, you can see here in this slide, if you are going for 10 rounds, okay, if you are going for 10 rounds, you can use the same 128-bit key you can use. I want to go for 12 rounds, means the length of the key will be changed. That means from 128 to, it will change to 192. If you are going for 14 rounds, I need 14 rounds means automatically 192 will be converted into 256. So depending upon the length of the key, okay, it is going to change. The number of rounds is going to change. You can see round 10 means it is 128. Round 12 means it is 192. Round 14 means it is going to be 256. So you are having by default, what is the size of your key? By default, my size is 128 is the default. By default, it is 128 bit. Okay. Then this will expand. We already studied what is expansion. Expansion means 128 will be converted into 192. 192 will be converted into 256. So you are having an expansion box. The expansion will make the key. Okay, depending upon the rounds. Okay, now you can see what is the plain text. Plain text is 128 bits. You are going to convert this into bytes. That means it will be converted into 16 bytes. 128 divided by 8. It will be converted into 16 bits. Then you are going for pre-round. What is going on pre-round? No need to worry. We can see in the next slide. Then round 1, round 2, round 3, up to n number of rounds it is going, and finally you are getting the ciphertext. Okay, so what is going on in these rounds? Okay, we must know about the rounds. Okay, now let me go to the next slide. You can see this is going to be the encryption process. So this is going on in each round. Okay, what is that? Now you see, I take the plain text, 128 bit. That means I'm converting into rows and columns. That means I'm converting into 16 bytes. Okay, so the 16 bytes of data is available here. So we are taking the ciphertext. Okay, we are taking the ciphertext, sorry, not ciphertext, cipher key. Ciphertext is the last. So we are taking the key. Now we are sending it into the algorithm. Okay, we are going for the round 1. Okay, round 1 algorithm. I'm going for the round 1 algorithm. Now, inside the algorithm, you can see there are 4 different steps going on. In each round, there are 4 different steps. What is step number 1? Step number 1 is sub-bytes. Okay, what is sub-bytes? We will see. Second round, shifting the rows. Third step, mixing the rows. Then adding the round key. So, there are 4 different steps going on in each round. First round is the sub-bytes. Second one is the shifting the rows, mixing the columns, and then we are having the add round key. Okay, there are 4 different steps. Okay, now I'm going for each step. What is going on? What is a sub-byte? What is a shift? Okay, rows. So this, okay, diagram, these 4 steps, if you complete, okay, automatically AES will be over. Now we are going for step number 1. Okay, let me copy the diagram here, so that you can easily follow it. See here. So the first step is sub-bytes. So what is sub-bytes? What is going on in the sub-bytes means, you can see. So sub-byte means 16 bytes of input. 16 bytes of input. Okay, 16 into 8. If you put 16 into 8, you are going to get 128 bits of data. Now, this will be divided into 4 rows and 4 columns. So this will be divided into rows and columns. So sub byte, what is the sub byte is doing? The sub byte is going to divide. It is going to divide, okay, the data into rows and columns. Okay, you can see the word text now. So 16 bytes of input are substituted by looking a fixed S table. So now we are going to use something called S box, substitution box. We are not studying about the substitution box here. So from the substitution box, it is taking some value. It is going to replace. Finally, it will convert the data, your data, into 4 rows and 4 columns. This is step number 1. Then, second step, shifting the rows. Okay, what is the shifting the rows? Okay, what it is going to do means, see, each 4 rows of the matrix is shifted to the left. It is going to shifting the place, left side, moving the bits. All entries that fall off are reinserted at the right side. Okay, that means shifting. Shifting means, okay, it will be like this. For example, 1 0 1 0. Okay, see, this is 1 2 3 4 means I'm going to shift it. So shifting means 1 bit I'm going to shift to the right means. So the 0 will come first. 0 will come first. Then 1 0 1. I shifted like this. This is called shifting. Shifting 1 bit. Then again, I'm going to shift this towards right. So how can I shift means, now you can see the last one will come as first. So 1, already we have 0, then 1, 0. This is shifting. So the first one, it is going to be shifting. It is shifting. Then first row, okay, they're having some condition here. First row, second row, third row, fourth row. Okay, what is the first row? First row is not shifted. I explained what is shifted. Okay, so you can see I'm going to shift, but what I'm going to shift, see, first row is not shifted. Okay, then second row is shifted 1 byte to the left. Then third row is shifted, okay, 2 position to the right. Then the fourth row is going to shifted 3 position to the left. This is called shifting. So the first row, I'm dividing the data into 4 rows and 4 columns. So first row, I'm not shifting. Okay, this is the formula. You cannot change this formula. You have to follow this. So first step, that means first row, it is not going to shift. Second row, it is going to shift 1 bit. Third row, it is going to shift 2 bits. So, okay, then the fourth row, 3 bits. 3 bits, it is going to shift. So this is called shifting the rows. Teacher, can I change this means? You should not. Okay, because AES algorithm is doing this. Okay, the algorithm is doing. So finally, you are going to get a matrix, the final, okay, matrix you are going to get. So this matrix is completely now shifted. So this is what shifting the rows is doing. Then the next step is mixing the columns, mix columns. Now you can see. Now we are going to play with the columns we are going to play. Okay, now what is doing? Okay, mix columns. So the mixed columns, see, each 4 columns, okay, you know, this is the columns. Okay, rows means this will be the rows. Okay, columns means it will be, okay, up and down. So the columns. So each column of 4 bytes now transformed using a special mathematical function. They are going to use some mathematical function and they are going to change it. They are going to transform it. Then this function, this mathematical function, what it is going to do? It is going to take 4 bytes of 1 column. It is going to take 1 column and outputs 4 completely new bytes. So 4 bytes from 1 column. Okay, column means it will be like this: 1 0 1 1. So it is taking all the data. Okay, 1 column. It is going to send it inside a mathematical function, and it is going to produce a new column. It is going to produce. Okay, it is going to produce a new column. It is going to produce. Okay, what it is doing, we are not going to see that. Okay, it is going to produce a new column. It is going to produce. So every column it is going to take, send it into the mathematical function. So after sending it into the mathematical function is going to change it into a different values. It is going to change. So that is going to be the mixed column. Then The next one is finally you are going to get, okay. So you are going to get only the rows and columns you are going to get. Now what you are going to do, you are going to add your key. That means you are going to do the XOR operation. Already in the last class we discussed about the exclusive OR operation. So your data plus the key, the exclusive OR operation will be applied. So whatever the output, the exclusive OR operation coming, this will be sent to the next round. Okay, next round. So again, next round, what they are going to do, they are going for the sub bytes, shifting the rows, mixing the column, adding the rows. Then go to the next round. Next round. So depending upon the number of rounds, okay, either 10 rounds or 12 rounds or 14 rounds, okay, the same thing will be repeated. Okay, so no need to confuse too much. Let me just summarize. You can understand in a very simple way. I will tell the major points. What is the major points means? Here, 128 bits of data, 128 bits of key. Okay, this is point number one. Number two, second point here, the data should be converted into bytes. If you convert the data, 128 bits, if you convert into the data into bytes means you are going to get 16 bytes. Second point. Third point, number of rows is going to change. So number of rounds, you can have 10 rounds, you can have 12 rounds, you can have 14 rounds. If you have 10 rounds, if you are going to have 10 rounds, okay, you can use the same key, 128-bit key you can use. If you are going to change, okay, the rounds, if you are increasing another 2 rounds, I need 12 rounds means automatically the key should be increased. If you are going for 14 rounds, automatically the key should be increased to 56. How you can increase means the same 128-bit key, by using key expansion concept, I can increase. Okay, by using the key expansion concept, you can increase. Now, you can go for the round. Inside the round, you are going to do 4 different steps. So the first step is sub bytes. That is, sub bytes means this is called substituting the bytes. So each byte of data, okay, what you are going to do means you are going to convert your data into rows and columns. Okay, totally 16 bytes of data. 16 bytes of data. So you can make it into row and column. How I can make it? You can make it as a, okay, matrix. Okay, you can see. I'm going to make a matrix like this. So I'm just going to make my data, okay, into 4 rows and 4 columns. You can convert your data into rows and columns. 1 minute. So you can convert your data like this, 4 rows and 4 columns. 1, 2, 3, 4, 1, 2, 3, 4. This is 16 bytes. So each one is going to be a byte. So this is 1 byte, 8 bits, 8 bits, 8 bits, 8 bits. Okay, then 8 bits, 8 bits. So if you put the total, okay, you will get 128 bytes. Good. So now, okay, my matrix is ready. Then first step, step number 1, I'm going to do the substitution. Okay, this here 16 bytes available. Okay, I'm going to replace with something else. Same thing. Here 16 bits available. I'm going to replace with something. So here my 16 bits available. I will replace with something. So this is the first step. Step number 1 is, okay, that means sub bytes. Then shifting the rows. So shifting the rows means first row, I'm not going to do any shifting. Okay, I'm not going to do any shifting in the first row. Second row, I'm going to shift. Third row also, I'm going to shift. Okay, and third row, fourth row also, I'm going to shift. So for shifting, there is a formula available. What is the formula means? So first row, no shift. Second row, you are going to shift 1 byte. So 1 position, you are going to move it to the left. Okay, I think left, I told right. I gave example right, but left. Then 2 positions towards your left. Then fourth row, 3 positions towards your left. So whatever the result coming, so that is going to be the input for the next level. So what the next level means? The next level is going to be the next column. So after shifting the rows, I'm going for the next one. Okay, I'm going for the next one. So what I'm going to do means this is the result. Next one, I'm going to shift the columns. Okay, we are going to shift the columns, we are going to shift. That is going to be the next, the third one. So here you are going to mix the columns by using some mathematical functions. So the mathematical function, it will replace the columns. Then whatever the output comes, the output is going to be a matrix. Now this matrix, now I'm going to apply exclusive OR with my key. So exclusive OR operation, A B bar plus B, okay, A B bar plus A bar B. In the last class I explained that to you. So it is going to do the exclusive OR operation with the final matrix, that is going to be your ciphertext. This is how the AES algorithm is working. Okay, so this is the working nature of AES algorithm. Okay, now the decryption. Decryption, the same steps, but in the reverse. Same steps you are going to do, but you are going to do in the reverse. Now you can see, first thing, adding the round key. Next step, mixing the columns. Shifting the rows. Byte substitution. If you are going for encryption, in encryption, byte substitution will come first. Okay, you have to do everything in the reverse order. We have to do it, all the four process. Okay, it is going to do it in the reverse way. So first thing, okay, it is going to do the add round keys, then mixing the columns, shifting the rows, okay, byte substitution. So the same thing will be repeated in the reverse order for the decryption process. So this is about the decryption process. Now, AES analysis. Okay, we are just going to talk about AES. Okay, just only one slide. So what does this means? You can implement this. You can implement AES as a software, or you can develop this as a hardware. AES algorithm is widely used. Okay, it is used in many places. Okay, it is widely used in many places. So you can use, or you can create this as a hardware, or you can create this as a software. Then till date, no practical cryptanalytic attacks against the AES have been discovered. There is no cryptanalysis attack. That means cryptanalysis attack means ciphertext, taking the ciphertext and break that. Breaking the ciphertext without any key. Nobody can do it. Nobody crack it. Okay, that is the exact meaning. Nobody can crack this algorithm. So far, there is no evidence. That means this algorithm is going to be very strong. Then, here you have an advantage. What does that mean? Flexible key length. You can adjust your keys. You can have 128-bit key. You can have 192-bit key. You have 256-bit key. So you can have different key as per your requirement. So this is also okay. It is also shows that is called. So there is no attack against this. Then, however, DES, the AES security is assured only if the correctly implemented and good key management. This is for both either AES or DES. You have to handle the key safely. The key should be very safe. If you leak the key, finished. If the key is missed, if the key is missed, if the attacker is taking the key, means no use. Not only AES, any algorithm, any symmetric key encryption algorithm, if the key is compromised, the algorithm is no use. Okay, so up to this, we are completing AES concept. Okay, so AES block diagram is very important. Okay, so you must know the block diagram. Then in each round, what is happening? There are 4 steps going on in each round. That is going to be a very important concept. Now, so let me go to the next one, the last topic in this lecture. This is Cipher block modes. Modes of operation. Okay, the word is very difficult, but there is nothing. Okay, what does that means? We are discussing about the encryption algorithms. We are talking about the blocks. Okay, we are talking about the blocks. Okay, now you see, this is my data, the whole data. I'm going to divide the data into blocks. We are dividing the data into blocks. Now, how to handle these blocks? Okay, how the blocks will be handled. Okay, that is called modes, block modes of operation. Okay, so this is the entire data, the complete data I want to encrypt. So before encrypting, I'm dividing into blocks. This is block 1 and this is block 2. Okay, I have 2 blocks here. Now, how these blocks will be handled? Okay, so that is called block, okay, modes of operation. Okay, now there are so many different methods available. Okay, there are different methods available. So the first method is ECB method. Okay, I will tell all the 4 methods, then I'll come one by one. So the first method is called ECB method, electronic code book method. Then the second method is called Cipher block chaining method. Third method is called output feedback mode or output feedback method, or we can say OFD method. Then, okay, only 3 is given here. No, there are 4 available. Okay, now I'll come one by one. Okay, now I'm going for electronic code book. No need to memorize. Don't memorize all these things. Directly go to the diagram. So using the diagram, you can understand very easily. Okay, so what is that? Electronic code book method. Okay, this is the first method. Okay, what is happening? Electronic, okay, code book mode. Okay, what does that means? See here. This is your plain text. Okay, this is the plain text. Okay, or this is my block, first block. And here, this is the second block. I have 2 blocks of data. So first block of data, I'm going to encrypt. I'm going to send it into the encryption algorithm. This is the ciphertext. Then second block of data, I'm going to encrypt separate. Now these 2 encryption text, I'm going to add together. You can see C1, C2. I'm adding the C1 and C2. I will send it to you. This is the first method. See, P1, P2. This is your data. This is a complete data. So this data, I'm dividing into 2 groups, 2 blocks. So block 1 and block 2. So first block of data, I'm going to send it. Okay, we are using a key. We are going to send it into the encryption algorithm. And you are going to encrypt it. You got ciphertext. Second block of data I'm taking. I'm going to encrypt the second block of data, the output. So C1, C2, I'm going to merge together. I'm going to send it to the receiver. So now the receiver is dividing into 2 blocks. This is block 1, block 2. Then block 2 separately is going to decrypt. Block 2 separately is going to decrypt. Then he is going to join this together. Plain text will come. Okay, if you have 10 blocks, okay, 10 blocks. Block 1, block 2, block 3, block 4, block 10. Block 1, encrypt it separate. Block 2, encrypt it separate. Block 3, separate. Block 4, separate. Then finally, you can add everything together and send it to him. This is called electronic code book method. So in this method, one block is not depending on another block. Every block is independent. Every block is going to be independent. They are not depend on each other. Okay, that is the point. Then go to the second method. The second method is 4.2. The second method is Cipher block chaining method. There is a chain. What is chain? Block 1 output will go to the block 2. Block 2 output will go to block 3. Block 3 output will go to block 4. So there will be a chain available here. What is the chaining method? You can find it here. So in the chaining method, what is going to happen means there is going to be a loop. Okay, a loop is going to be available. Okay, what is the chaining? Okay, now you see. This is my plain text. Okay, I'm taking only 1 block. Okay, I'm going to have 1 block. Okay, this is my plain text. Now, so I'm going to send it into the encryption algorithm. Okay, I'm going to send it into the encryption algorithm. Then this is the key. This is the key. Okay, this is the key. Now I'm going for the next round. Okay, that means the second block. Okay, I'm taking the second block, or I can say this is called a value. This is called the IV, initialization vector. Okay, initialization vector. So what initialization vector IV means, that is some initial values. Some value I'm going to store here, some random values. Now I'm going to do the exclusive OR operation. Then again I'm going to encrypt. That means, you see, you take first block, I'm going to take. First block I'm going to take. I'm going to apply exclusive. Okay, I'm repeating my words. I'm telling in a different way now. Listen, I take my plain text. This is one block. Now I'm going to apply the exclusive OR operation. Okay, I'm going to apply the exclusive OR operation with what means with IV. What is IV, teacher? IV means initialization vector. Okay, IV means initialization vector. What is this initialization vector? Some random number. Some initial value x equal to 0, x equal to 1. Okay, you are going to initialize. So some value here, this value, okay, that means a random number, a random value. I'm going to encrypt by using, okay, I'm going to apply the cipher, okay, that means exclusive OR, I'm going to encrypt. Then whatever the output comes, I'm going to take it here. Now my initialization vector is going to change. Okay, this encrypted output, whatever coming, this is going to be my IV now. Then I'm taking second block of data. Then second block of data, I'm going to apply the exclusive OR encryption. Then I have third block of data, repeat. I have fourth block of data. Now my block of data is over, means you will send your ciphertext. Okay, teacher, I didn't understand. Okay, 1 minute. In a very simple way, let me explain, okay, so that you can understand better. Okay, now you see, this is block 1, B1. Okay, block 1. I have block 2. I have block 3. I have block 4. I have 4 blocks of data. So I take block 1. I'm going to apply this with the exclusive OR operation. This is exclusive OR operation. With what? Okay, I'm here. Block 1 I'm taking. I'm applying exclusive OR operation with the initialization vector, IV. What is initialization vector? Some random number, some random value or some random numbers. Okay, then I'm going to apply the exclusive OR operation for block 1 and initial value. Then the output, it is going to generate the output. This I'm going to send it into the encryption algorithm. Okay, I'm going to send it into the encryption algorithm. So inside the encryption algorithm, I have B1. I apply the exclusive OR operation. I apply the exclusive OR operation with IV. So this is, I'm going to send it into the initialization vector, encryption. Now I'm going to get C ciphertext, let it be 1. Ciphertext 1 I got. So I'm here, I got ciphertext 1. Now the ciphertext 1, I'm going to use it as IV. Okay, now I'm going for the second step. I take B2, block 2. I'm going to apply the exclusive OR operation for block 2. What is the initialization vector means? Okay, so initialization vector is going to be CT1, ciphertext 1, the output of previous. This is called chain, CT1. So this now after, okay, I'm going to send it into the encryption algorithm. Then whatever coming, it is going to be CP2, ciphertext 2. So now ciphertext 2 will be used here, ciphertext 3 will be used. So this is called cipher blockchain. So what you understand means, in the previous method, blocks are separate. First block, second block, third block, separate. But here not like that. Here every block is going to be used as a chain. Okay, every block is going to be used as a chain. So this is the encryption. The same thing is the decryption also. Okay, it is going to be the decryption. So this is the chain blocking. That means the cipher block chaining method. Then go to the third method. Third method means, the third method is feedback method. Okay, you have to see the diagram and you have to write in your own words. Okay, now what is the next method means? The next method is going to be cipher feedback mode method. Okay, it is almost same like the second method, feedback method. So what is the feedback method means? So here also the same thing. chain. There will be a chain available. What is that? You see, I'm taking the plain data. Okay, I'm taking the block. Okay, I'm taking the block. I'm applying the exclusive OR operation. This is the exclusive OR operation. Okay, I'm applying the exclusive OR operation. Very good. With what means that we will see later. Okay, I will tell that later. So I'm applying exclusive OR operation. Then whatever the output comes, I'm going to take it to the next level. Same thing we have done in the previous. We are using the exclusive OR operation. Then you are encrypting. Then you are using as a chain. Now, after exclusive OR, I'm going to take it. I'm going to use shifting. The shifting we are not doing that, but here we are doing shifting. Now I'm going to shift one bit left. Okay, for example, here if I get 1100 means in 1100 one bit you have to move left. So then I'm going to do the encryption. So this step is not available in the previous one, but here we are adding shifting. They're adding something extra now. Then I'm going to encrypt. Encryption is available there. Then after encrypting this, you are going to select some bits. Okay, this is called. Okay, we are going to select some bits in the left side. You are not going to take everything. Some bits you are going to select. Okay, some bits you are going to select. Okay, the same thing. The previous one is same, but here only shift to the left is available. So you are going to take some bits from the MSB. Okay, most significant bits from the left side. From the left side, you are going to select some bits and you are going to use it here as the exclusive OR operation. So this will be repeated. So some encryption algorithms, okay, they will do like this. Some encryption algorithm, okay, we already discussed 3 methods, okay, including these 3 methods. So how these blocks will be handled? So every method, every encryption method will handle the blocks in a different ways. Okay, it will handle the blocks in a different ways. Okay, this is the third method. Now, let me go to the fourth method. So this is also a feedback method. That means a chain will be available. You can see the fourth method. The fourth method is output, okay, feedback mode. Now, can anyone just see the diagram and you can tell what is happening here? Do you use exclusive OR operation here? Any one of you, please answer your question. Okay, my questions. Do you use exclusive OR here?
No.
Exclusive OR. This is exclusive OR operation. This is exclusive OR operation. Okay, let me tell. Okay, now you see. I take the initialization vector. IV means initialization vector. What is initialization vector? Some random numbers. Okay. So some random numbers available here. Okay. I take the random number. I'm going to do, okay, I'm going to encrypt. E stands for encryption. Okay. So once if it is encrypted, I'm going to get some value. This value and your first block of data. First block of data, I'm going to encrypt. Okay, that means I'm going to apply exclusive OR operation. Okay, this is going to be my first block. Then second one, I'm going to use a shift left. Okay, I have some bits here. Okay, for example, if you have bits here, okay, so I just take, this is my initialization vector, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bits available. So 1, 0, 1, 1. Okay, so some 10 bits I'm having like this. Okay, for example, you take. So first round, I'm going to use this. Okay, I'm going to encrypt it. Then I'm going to do the exclusive OR operation with my data. This is going to be first segment, first block. Second block, what I'm going to do? I'm going to do shifting. So in this, I'm going to do shifting left. So shift left means this one should come. Okay, go to the left, go to your right. So the data is going to become like this. Okay, this is called shifting. So the data is going to come like this. One will come here. Then I take the second one, I'm going to encrypt it. Then the second block of data, I'm going to do the exclusive OR operation, send it out. Then the next one, again, I'm going to shift. So in shifting, the last 0 go to the end. Now you can see Okay, the last 0 should go to the end. So I remove this 0. Okay, this is called shift left. This is called shift left. So if you have 10 blocks of data, for every 10 block, you are going to do shift. If you have 2 blocks of data, 2 times you are going to do. So this is called output feedback mode. So different algorithms are going to work in different ways. Okay, there are 4 different methods available here. So these 4 methods, by using the diagram, you can write it. Okay, you can write it by your own words, but you must know the diagram. Okay, the block diagram. So first one is electronic codebook method. Second one is Cipher blockchaining method. Third one is Cipher feedback method. And fourth one is output feedback mode method. So this is how. Here IV, there is a word available, IV. So IV means nothing. It is called initialization vector. So initialization vector means it is some random numbers. Okay, automatically your algorithm will randomly select some numbers. Then now one more important keyword is exclusive OR. This is the exclusive OR operations. Some algorithm will use this exclusive OR operation. Some algorithms, they may not use this exclusive OR operations. Okay, so this is the concept of this particular lecture. The lecture is quietly big. Okay, it is long.